Okay, for the mobilization enzymes, these are the discussions. So we will start to talk about the author Sung Wang in 2009. He announced the points that the efficiency of an immobilization process can be measured by the following criteria. So the most important of all, he said that a high percentage of the enzymes must be initially retrained in the GL matrices. Secondly, the enzyme's activity must be preserved. And thirdly, the enzymes must be physically restrained from diffusion back into the substrate solution at later time. So it's a little difficult all these points. So to create a fine and uniform mesh, so to prevent the trapped enzymes from linking out of the matrices, he proposed that the one of these points, and on the other hand, highly cross-linked matrices can result in higher mass transfer resistances from both the substrate and the product. So in this part, we show you the abstract of our first principal references about the alpha amylase and immobilization of this one. So these authors that Fiyin Ertan, Hula Jargar, and Bilal Bakar in 2007 talk about the effects of the immobilization and the conditions, so such as to the arginate concentrations and the calcium chloride concentrations amount of loading the enzyme. So uh, in the bedsides too. So they use to the optimum alginate of calcium chloride, sorry, the concentrations were found in the 3% wave volume using an learning enzyme concentrations of 140 units per milliliter. So, and the bed's diameter is of 3 millimeters. So, amount this 0.5 grams maximum enzyme activity was observed. So, they use these parameters, and we have in our experimentation we took the reference of this article. It's indicated in the table number 1, and this authors makes the computations of between different concentrations but alginate of calcium chloride, demonstrating that the concentrations are optimal for the enzymatic activity. When the alginate concentrations was increased from 1 to 4% with volume, the highest of alpha amylase activity was found in the 3% among and equal the same part in the calcium chloride concentrations tested by the best for alpha amylase activity was observed in the 3%. So the table number 8 shows the elusive efficiencies of the enzymes, and it can see the values are low. The lower mobilization yield in case of lower percentage of solid sodium alginate might be due to larger pore size and consequently greater link of enzymes from matrix. This was seen by Day in 2003, Kansawut in 1989, and Mamo and Jesse in 1997 suggest that the mobilizations of the cells generates low levels of enzymatic production compared with the free cells. So we hope to have more activity with the free cells that in the immobilization cells of, well, these there are not cells, are proteins of alpha amylase. So the diffusion barrier generated by the alginate maybe really will reduce the ability of the contact with the substrate. So for another point, the size of our bits are for 2.59 and 3.07. So the Earton reports that the best size of their bits are for 3 millimeters. So which we experimented have we have, and we hope to have the best activity acceptable for the enzymatic resources, and because the size of a significant effect on the speed of enzymatic reaction, and this determines the stability on the reactor configurations. for the form of the react with the substrate and enzyme. Are smaller bits and are expected to show the greater catalytic activity due to lower resistance to substrate transfer. So in this part, I will show you our graphics, our tables, sorry, and we show you uh, the size of our bits and our percentages of immobilization of enzymes, like in the results. And that's all. Thank you a lot, and I hope to you skip see us. See ya.